To start the static electricity. So basically today we will cover the static electricity, which is the build-up of a charge on insulating materials. Do you have any idea, Ayan, what does that mean by static electricity? Any specific definition do you have?
Charges on objects.
Yes. So this static electricity is the accumulation of electric charges on the surface of object. Any object, any of the surface of the object have a charge. That doesn't matter the charges are positive or negative or maybe together. So this is called static electricity. So it generally occurs when two materials are rubbed together. So same thing we are doing in the last class. The polythene rod is rubbed with the cotton or with the silk cloth. So one of them will become static because the movement of charges from one body to another. Okay. So by looking at the picture, so build-up of a charge on insulating materials. For example, this is like there is an object and this is the insulating material. Insulating materials are the material they cannot process, they cannot pass the charges, they cannot pass the electric current. So when we rub that insulating material with the conducting material, so that conducting material will transfer its charges to the insulating material. This is basically known as static electricity. So the cancel out, like this is a positive protons and this is negative protons. And now all the materials contain charge because they contain positive protons and negative electrons. Okay. And normally, though these charges cancel each other, which means that most materials are neutral overall. But this is a plus and a minus. They're going to attract each other. And by their attraction, they will cancel out each other. So in that way, that material will become neutral overall. Will become neutral. Okay. If materials are rubbed together, though, like a bag and a hat. For example, if we rub, this is a bag and this is a hat. Then the friction between the two objects causes the electron to be rubbed. When we rub the two objects, the insulating object, so the charges between them also be rubbing in that situation. So object causes electrons to be rubbed off one of them and onto the other one in conducting materials like metal, where the electrons are able to move. So one of them is the body of the conducting material in which electron easily can move. They will shift their place. They will move to one place to another. An electron just flows straight back again. So no change ever builds up. In insulating materials, though, like a polythene, no, this is the insulating materials. Okay. So there is a no change. When they go back to their places, they come back to their places as well. So there is a no change, nothing static electricity will be happen here. But if we take a different, like a friction between these objects, friction will be produces, like the frictional force. When the two things rub together, they produces a frictional force that opposes the motion. Okay. And another example is like in insulating materials like a polythene rod and a cloth. The electrons can't flow back. For example, if I just take an example of cap and a hat. If we rub together, the electrons or maybe the protons of the cap will shift to that bag and they will come back to the hat as well. But there's a situation in which when the charges move to the another place, they will not come back to their original place. Okay, and why that has happened? Because the transfer caused by the friction leaves a positive static charge on the material that lost the electrons. In this case, the cloth and the negative static charge on the one gained them. So the polythene rod, which way the electrons get transformed each time depends on the specific material involved. So if we have to produce a static electricity, we must everything is depend on the material we are using. Yes?
Doesn't it depend on the electrons?
Yes, it depends on the electrons of the body. It depends upon the electrons of the material. Okay. So if I like the object that gains electron become negatively charged, while the one that loses the electron become the positively charged. Is it? And charging method. For example, if we have to charge something, what will be the method? The friction, the conduction, the induction. These are the method by which an object can be charged. Friction, we have to rub the two opposite things. ठीक है. Okay, then the charging. So this is a method, charging by friction. Okay, so today we will read about the static electricity and how we can produce static electricity by the different methods. This is a charging by friction. So this occurs when two insulating materials are rubbed together. One material loses electrons, becoming positively charged, while the other gains electrons and become a negatively charged. For example, rubbing a plastic rod with a cloth. Best example. Okay. Now the charging by the conduction. This is an example of a friction. I hope you get the idea. Do you have any question here, Ayan?
No.
So the conductive materials, no charge ever builds up. Here is no charge when there is no rubbing between them. Okay. Now we have to do with the insulating materials. How an insulating materials can produce static electricity. Okay.
Okay.
So the concept of materials involved. For example, if we look a similar cloth and use it to the rub, the electrons would get rubbed off, and this is the whole idea about this. Now we have to do for the insulating material. For the electrons can't flow. This is a polythene rod, negative static charge. What does this mean, static? What is the dynamic and the static? Static means the charge that is not movable. Dynamic, that is movable, that is showing a motion. Okay. So the induction is when a charged object is brought near a neutral object. Charge object brought near to the neutral object. It causes redistribution of charges within the neutral object without direct contact. Without a direct contact. Is it?
Yes.
Okay. So this idea will be like, for example, if we took a similar cloth and use it to rub an acetate rod. This is a similar cloth and this is an acetate rod. Okay. Use it to rub an acetate rod instead. Then the electron would get rubbed off and the acetate rod, leaving it a positive onto the cloth. All the electrons will move to the cloth and the rod becomes positive acetate rod here. Okay. And onto the cloth, making it negative, and that are transferred. The positive static charges occur because an object has lost negative charge. Positive is become because it loses its negative charges, is it? And not because it gained positive protons, because it loses the negative electrons. And the next thing, here we need to look at this. What happens if an object keeps on gaining negative electrons? As more and more electrons are transferred and the size of the charge increases, a potential difference will develop. If the negative charges, they are like gaining continuously one by one, and the charge, the size increases, in that situation, potential difference is developed between the charged materials and the earth or any earth object like us, because remember, when objects are always at 0 volts, if the potential difference between the charged object and the earth object is large enough, then electron can jump across the gap. And that jumping electron is what is a spark is. And one thing we need to point out is that charging can sometimes build up on conductors too. So what is the idea they're discussing here? They're telling like when a charged object is brought near to the neutral object for the induction, it causes redistribution. Redistribution may be if there is a positive, in the positive they move to the negative, and the negative they move to the positive. So this is a redistribution of the charges. If they are distributed first, now they again redistribute themselves. Okay. And the side closest to the charged object becomes oppositively charged due to the attraction of opposite charges and repulsion of the like charges. If these are two, the negative, they will attract each other. Few of the minus will go here, few of the plus will go here. And their like charges, they will repel each other. All the charges will be redistributed. Got it?
Yes.
Any question?
No.
So which way the electrons get transformed depends on the specific materials. Look here, this is the cloth is negative. Here is the associated rod is positive. The positive and the negative will shift their places, maybe attract together, maybe repel together. But here is a negative static charge, here is a positive static charge. Situation is changed according to the material we are using. Got it? Okay, then next we have the same thing. Only negative electrons that are being transferred. Only negative electrons. Okay. Now here is the electron from this cloth will go here, and the lost negative charge. Lost, and here is coming here. Okay. And what do you think about an like earth object, for example? It is much less common. For example, cars can build up charge because their metal frame is in a contact with the wind, which can transfer electrons. The car we are driving in the way, the wind is coming toward the like making a friction with the surface of a car can produce its own charges because the wind, the air has ions and the electrons on it, and maybe the surface of the car has also the electrons, maybe opposite from them, maybe same from them, like. And because their metal frame, you have probably experienced this yourself when you have touched a car and got an electric shock. Have you experienced this thing? Yes, this thing happens when the charges the present in the wind, in the air, they make a contact with the surface of a car, and they produce a smaller electric and a static electricity. This is just a small spark from the car discharging on the earth through your body. For example, you're rubbing the rod with the cloth. Maybe your body will become an earth object. Maybe your body will receive the few charges, maybe like charges, maybe unlike charges, and your body will become an earth object. The charges will become to the body, and your body transfer to the ground. And the same thing will electricity, static electricity. All the charges are moving around here and there. So anyway, this is the topic, and this is the thing in which we discuss about how the static electricity is produced by the conduction, by the induction, and by the friction. Okay. And what do you think about the conduction? When the charged object comes in contact with a neutral conductor, it transfers some of its charges to the conductor. Okay, the insulating material converted into transfer the charges into the neutral, and same thing for friction, same thing goes for the friction, conduction, and induction, for both of them, three of them. Okay. Now if I ask the question like what is the difference between and how the charges are transferred between the conductors and the insulators? So conductors are the materials that allow electric charge to move through freely them. Metals like copper and aluminium are good conductors because their atoms have loosely bound electrons that can easily move. Insulators, on the other hand, do not allow free movement of electric charges. Materials like rubber, glass, and the plastic are the good insulators because their electrons are tightly bound to the atoms. So when we talk about the static electricity of the conductor and insulator, which one will produce good static electricity? Do you have any idea?
Maybe one which is the best conductor.
Maybe this is an important question about this topic, that which will produce a good static electricity, friction, induction, or conduction? This can be a question which comes up in your exam as well. What do you think about this?
Maybe.
So friction is the good thing, conductor is the good thing, or insulator? What do you think about which one?
Insulator is the bad thing. It cannot conduct.
No. If I ask about if I need a good example of static electricity in which the charges are transferred from one body to another, they are showing same charges and the like and unlike charges, they are showing a strong static electricity, they are producing a spark. So you think that insulation is the best method?
No insulation. Maybe convection.
Okay, so if I talk about the friction is the method that produces good static electricity, because when two different materials are rubbed together, electrons are transferred from one material to other, creating a static charge. And this process is commonly observed when you're rubbing materials like wool and the plastic or balloon on your hair. Is it? When you like rub balloon in your hair, you feel a static electricity. Your hair is like attracted towards the balloon. So
So
the
why not convection then?
why it is not the induction and the conduction good for the static electricity? They have their reason. Because induction is the way of redistribution of charges without direct contact. Induction does not produce a static electricity on its own. It only rearranges the charges in a neutral object when a charged object is brought near to it. For example, this is a neutral charge. That is not a specific charge. For example, this is a body. It is a neutral charge. But in the friction, both of bodies have the charges when they rub together. In the induction, they have a neutral charge. And then, for example, if a body have a both charges, plus and the minus, one of them will be distributed to the neutral charge body. Example, if a negatively charged rod is brought to a neutral metal sphere, the electrons in the sphere are repelled and leaving one side positively charged and the other negatively charged. However, the object remains electrically neutral overall unless grounded or separated. If we just put that grounder, like the charges will be transferred to the ground, that body will become a static electricity, but not without the grounding but the separation. Got the idea?
Yes.
Very good. So now the conduction. Conduction involves direct contact between a charged object and the another object, resulting in a transfer of electrons from one to another. For instance, if a charged object touches a neutral object, the neutral object may acquire the same type of charge. However, this process does not create a new charge. It simply transfers the existing ones. Same thing. It's like just transferring the charges from one body to another. But in the friction, the charges are transferring, they are producing a shark, they are producing a little bit current, static electricity. So the static electricity that we want to generate has already been created elsewhere. So the conduction does not actively produce a new static charges. No, they are using their previous charges to produce a static electricity but somewhere else, but by the help of separation or by the grounded. But friction, they both are charged and both are producing static electricity in the present situation, not with the grounded, not with the separation. Okay.
Okay.
So in a contrast, friction generates static electricity by creating an imbalance of charges. When the two materials are rubbed together, one tends to gain electrons, becoming negatively charged, while the other loses electrons, becoming a positively charged. And this process creates static electricity from scratch. Got it?
Yes.
Okay. I hope you get the idea of the static electricity about the induction, conduction and the friction. Everything is clear? Any question?
No.
So these are the like earth, any earth object, and the jump across the gap and the earth, size of the charge increases as the potential differences increases. This is a charge, this is a wind, and I just gave you the example. Okay. Static electricity, and we feel now the static electricity. Now get through the basic ideas of static electricity again from the daily examples. So the result of an imbalance between negative and the positive charges in an object, and that imbalance of the charge is only shown by the friction, not the conduction, not the induction. Okay.
Okay.
Static electricity. One way to generate static electricity is via friction. No, look here. I hope now you get the idea. Okay. And for instance, rubbing a plastic object with the cloth. Plastic object with a cloth. And then The plastic rod is rubbed with the cloth and both become charge rubbing cases. Causes electrons to move from cloth to the rod. Now this is a cloth with a positively charged and the rod is a negatively charged. When the plastic rod is rubbed with the cloth, the both becomes charge rubbing. Causes electrons to move from cloth to the rod. They're continuously moving and they're like causing a spark between them. And when the cloth is close to the rod moves towards the cloth. Have you ever experienced this kind of thing? When we rub things together, when we just make a little bit distance between them, they will attract with each other because they become a charged bodies. One is positive, one is negative, and both of them will attract together. Okay. This is the best example of static electricity when we used to do in our childhood when we rub our hair with a ruler or with a scale. When you bring that ruler and with the pieces of a paper, the scale will attract that pages. Is it? Have you ever did this experiment before? Right now, can we do this? Do you have any scale, or can you bring that? Let's just do this the static electricity practical. Okay. And make a few pages and the pieces of the paper. Done the idea about this, how the charges is distributed and how the charge is attracted and how static electricity is produced. Okay. And the static electricity, now when the second rod is rubbed in the same way and brought close to the first one, the hanging rod moves away. For example, we have two rods and we rub both of the two rods with the cloth, and we know that the cloth contains the positively charged. The cloth is positively charged and the rod becomes negatively charged. When we brought two negatively charged rods together, they will repel each other. That is known as a repulsion. Got it?
Got it.
Very good. And the next thing, when the positively charged and the negative charge, these two will show the repulsion and these will two show the, yes, Ayan?
Attraction.
Very good, attraction. These will show the repulsion, this will show the attraction. This is a positively charged, this is a negatively charged. And after that, yes,
The same charge is repelled.
yeah, same charges. Oh, this is also the best example of static electricity. I hope you guys have a balloon in your house. If you don't, you can do the practical as well. You like blow the balloon and then rub it with your hair. When you move a little bit away from your head, it will attract few of your hairs. Maybe if you have a little sister, maybe she has a long hair. So you can do this practical of static electricity with her as well. Okay?
I did this before.
Very good, very good. And I hope you got this idea before.
No, I didn't get the idea before. I got it now.
Oh, now? Okay, very good. So the explaining static electricity. Now we got the idea. What do you think about doing it like one more time? We can do this one more time, okay? So the explaining a static electricity. Before we understand how things are charged, we need to understand how an atom is. So basically this is a function of atom. Atom that has a proton, that has an electron, that has a neutron. So that the body is made up of atom, tiny particles. The charges is moving. But we have to understand the concept of the atom as well. So the positive and the negative charge in an atom are equal. So overall an atom has no electric charge. We say as it neutral. When atom becomes neutral, when the positive and the negative charge in an atom are equal. For example, this is 2 protons, 2 neutrons. For a proton, 2 neutrons. 4 protons, 4 neutrons. Then electrons will be equal. Then that atom will become neutral because everything is same. Nothing is changing, nothing is decreasing. And that is way how an atom becomes neutral. And that is how our body becomes neutral. Okay. Electrons are negatively charged particles and they are relatively weakly held in the atoms. Okay, electrons are the negatively and they have like held a very weak force. If they like move away, they have a strong. When they move together, they have a weak force. And the nucleus contains proton and the neutrons. Proton is a positively charged particles, and the neutron is like a neutral. It doesn't have a specific charges. This is a specific function of atom, a structure of atom. And I hope you know this before, what is atom and what is structure and what its major subscripts. Is it?
Yes.
Okay. So explaining static electricity after this concept. It is a force of friction that causes charging. So the electrons and the electrons. This is a cloth, loses the electron, becomes positively charged. Like this is a gains electron, it becomes negatively charged. These two are rubbed together. It will loses its positive charges, its positive electrons. Loses electron. It loses electrons. All the electrons in the cloth, it will loses to that rod. Why it will lose its electrons to the rod? Why? Do you have any answer about this? Why the cloth loses its electron towards the rod?
Because the rod is positively charged.
Yes, because of the force of attraction. And why the rod gain electrons, it become negatively charged?
Because when they attract each other, then the electrons in the cloth will move onto the rods, making the cloth positively charged, and then the rod negatively charged.
Yes. So the electrons that are losing by the cloth, the rod will attract them. It becomes negatively charged because of the opposite charges, unlike charges. Okay. So now the conductors and the insulator, because conductor and insulator are not the best example of static electricity, but they like produce in another state with the grounding or with the separation. A substance that allows the flow of electron, for example, metal, gold, and copper. A substance that inhibits the flow of electron, for example, plastic, glass, and then amber. Charge can move through conductors but not insulators. Reasons. In insulators, the electrons are tightly bound onto their atoms, not easily removed. But in the conductor, they're not like that tightly packed. They can easily move from one object to another. So electric field, do you have this topic in your like electric field, is it now? Because if you're going to discuss about the charges, so there should be the presence of electric field. So this is the basic diagram of positive charge and the negative charge, and you have to remember this and you have to draw this as well for your practice. That positive charge always directed outward and the negative charge always directed inward. Okay, this is an electric field. Field means this is a charge, electric charge. Their surrounding by their fields will show the attraction or the repulsion sign. Okay. Definition. A region of a space in which an electric charge will experience a force. The line of a force are shown coming out of the positive charge into the negative charge. Okay. An electric field. If a charged object moves into the electric field of a charged object, it will experience a force and it will attracted or repelled. So if they're attracting, if they're repelling, this is because of the kind of a force. Okay, that is the force between the electrical charges. Maybe repulsion or maybe attraction. Electric field. For example, let's consider this example, the two parallel plates with an opposite charges. This is negative and this is positive. Now all the forces is coming from the positive and going towards the negative, because positive is away from and the negative towards. Okay. And the charged particles. Electric charge is measured in coulombs. We learned this thing, na?
Yes.
Electric charge is measured. This is a unit of the charge and named after the Charles Augustin de Coulombs. He discovered that the force between the two charged objects depends on how big their charge or on how far apart they. Because if you're going to study about the charge, you have to do the value of the specific given data. If you have to do the specific numerical questions. So the one electron has a value of 1.6 multiplied by 10 to the power minus 19 coulomb, and the one proton is, because proton and electron are the same, but electron is counted as a negative because of the negative charge, and the proton is positive, which is considered as a positive. We have to memorize these values, okay?
Okay.
And this is the next question, and this is a question related to the topic. Now this is for your task. Can you do this? You have to give me the answers, okay?
Okay.
What is the definition of an electric field? A region in a space in which a mass experiences a force due to the Earth's mass. A region in space through which electromagnetic radiation is passing. A region in space in which a compass needle experiences a force. A region in a space in which an electric charge experiences a force. Choose correct option.
Option D.
Option D. A region in a space in which an electric charge experiences a force. Very good. That is the correct option. So I will give you here marks as well because we are doing the quiz, is it? Which of the diagram below shows the correct electric field pattern for the positively charged particle parallel plates? Sorry. Which one? According to their sign.
Option number B.
B. Very good. That is the correct answer. This is a positive going towards the negative. Very good. And you also get here 1. Okay. The plastic rod is rubbed with the nylon cloth. This process causes electrons to be transferred between the rod and the cloth, causing both objects to become charged. Which of the rows in the table below correctly gives the nature of the charge on both the cloth and the rod and the effect the object have on each other after becoming charged? A. Same, the same, repel. B. The same, attract. C. Opposite, repel. D. Opposite, attract. Charges on the rod and cloth affect. What will be the correct answer?
D. Option number D.
D. So when the plastic rod is rubbed with a nylon cloth, the electrons are transferred from one object to other. This causes the rod, the cloth to have opposite charges. One become positive charge and the other become negatively charged. So the opposite charges are attract each other. So the rod and the cloth will attract. They become opposite and they will attract each other. Very good. Here you got the again. Now the last one. A student rub a polythene rod with a cloth giving a negative charge. She then, okay, it is not visible by me. That is the not the clear screenshot. Let me read it again. That was a screenshot from the paper, so I think it become blurry. Wait. I think I do have that paper. Let me open that. Then I will read it to you and you will explain it to me, okay?
Okay.
So this is the question is, a student rub a polythene rod with a cloth, giving it a negative charge. She then holds it near on earth conducting sphere as shown in the diagram below. Which of the following shows the correct distribution of charges on the conducting sphere? First one is the negative and then A is positive and the negative. This is the negative, this both is positive. And this one is the negative, whole is negative, and this is the negative and this is positive. This is negative, this is positive and negative. Which one shows the correct distribution of charge on the conducting sphere?
Option number D.
D. So it shows a correct because both has the, yes, both has the, here is a negative, here is a positive, and both have the different charges and the charges are redistributed. If both get a different charges, that is not the proper redistribution. So the correct option is D. Okay, how many? 1, 2, 3, 4. Okay, you got 4 out of 4 today in the quick quiz. Okay, and you got the 3 stars as well. And I hope you get the idea about the whole static electricity, charging, discharging according to the conduction, induction, and the frictional force. Do you have any question for today's lecture, Ayan?
No.
So we can say that's the so far so good. Yes, very good.